Okay, we have a scenario where we have two sleds, which I'm just going to draw as squares, all right, with a rope in between both sleds, and then another rope, and a dog, which I cannot draw for the life of me, so we're just going to write dog. Okay, we're going to call this one M1, we're going to call this one T1, we're going to call this M2, we're going to call this T2, okay? Now, we know that this M1 has a mass, so we can say M1 is equal to 104.0. M2 has a mass of 87.4. We have also mu k, which is the friction with the snow. So we have to imagine, maybe blue is more representative, that there's snow over here. The friction with the snow, we're going to call this mu k, is going to equal to 0.090. And then we have T1, which is going to equal 140 newtons. Okay. Sorry. First thing that we have to figure out is how are we going to actually split this question up? Because usually, the way that we would usually go is that we would make some kind of Fy and Fx and then somehow substitute in those equations, and we have a full-on whatever Fy and Fx equal, and then we solve each one. But in this case, we don't actually have an Fy. The force is moving in this direction. The sleds are moving in this direction. We don't have an angle theta on which they are moving. There is no angle theta. So they're all moving in one direction. So in fact, we're not even going to have to use an Fy. So if I make my equation, which I will do Fx is equal to M2a, which is equal to T2 minus T1 minus mu k, M2g, okay? We rearrange that because we want to solve for T2. I don't think I mentioned that. We need to solve for T2, the tension in the second rope. So this will become T2 is equal to M2a plus T1 plus mu k M2g. Okay? Now we have M2, okay? We have T1. We have mu k. We have M2. We have G. All of these we have except for the critical A right here. So we're going to quickly solve for that. I'm just going to scroll down. I'm going to do it in this red so that we know what I'm doing. Let's quickly solve off to the side a little bit, okay? We're going to do, what are we doing? We're going to do the summation of Fx, which is equal to M1A, which is also going to, I don't have enough space. I'm going to actually do it below this, so let's go back. Okay. We have, terrible line, that's what we have. We have summation of Fx, which Fx also equals M1A. M1A becomes equal to T1 minus mu k M1g, which we can actually plug in. And if you go do that with me right now, we can rearrange for A, and that's going to equal to T1 minus mu k M1g, all of that divided by M1. Okay, let's go plug that in. So I'm going to scroll back up in a second. Our T1 is 140. We subtract from that. We subtract mu k, which is 0.09, times M1, which in this case is 114, times G, which is 9.81. And then we have to divide our answer by M1, which is 114, and we should get 0. Sorry, let's do it right here. We should get 0.345. You guys can keep going. 1, 7. Oh my god, 345. Okay, so weird. Anyways, we go back up here to this. We can now plug in all of our values. Okay, so M2 is equal to 87.4, which we're going to multiply by A, which we found to be 0.34. Remember, 5 rounds down. If it's an even number, we add T1, which is 140. We add to that plus mu k, which is 0.09, times M2, which is 87.4, times G, which is 9.81, which we should get equals to wrong number. 246.8816. You can round that, so it just becomes 246.88 newtons, and that is how much tension is in T2.